We have another example here of a mean value theorem problem. Um, I tightened up the definition of my mean value theorem just a little bit here. If you saw my previous video, we ended up with two possible points, one of which was at the end point of the interval and one of which was somewhere in the middle of the interval. And if you look up a textbook definition, the mean value theorem is going to give you a value in the open interval. It's not either of the endpoints. It's somewhere in between the two endpoints is where your point is guaranteed, just so you know for future reference, because I was a little bit lazy in posting that. Anyway, so the mean value theorem basically tells us that the average rate of change is equal to the instantaneous rate of change or the derivative at some point in an interval if you have a function that's continuous and differentiable in the interval. And so anyway, notice here at the start, they tell us that we have a function that's continuous and differentiable, okay? And frankly, that's a little bit of a red flag to me saying, hey, we've met the requirement for the mean value theorem. Could be mean value theorem, okay? Not to say that it has to be. Let's look at the choices here, okay? So part A says, oh, the minimum value of f is 2. And, you look at the chart here and you say, yeah, that sounds good. The smallest value we have here for this function is 2. Yeah, sounds great. But remember, they tell us that this function is continuous, okay? So we have absolutely no idea what this function is doing, okay? This function could come through here and it could dip way down here and then it could come back up and do that sort of thing, okay? So we don't necessarily know that that's the minimum value. It's the minimum value that they show us, but it's not necessarily the overall minimum. Same kind of thing with part B. The maximum value is 4. Well, it's the highest number, but we don't know again that the function doesn't come through here and we don't know that the function's not going to come through here and go way up here somewhere and do something like that. We have no idea. We don't know that. It's continuous, so we don't know what happens in between those points. So anyway, part C says f of x is always greater than 0. Okay, once again, we don't know anything about what this function does. F of x could dip way down here and be less than 0. Okay, somewhere that could possibly happen. Okay, anyway, f of x says here on part D, that's f prime of x is less than 0. It says that's telling you that the derivative is less than 0 between 2 and 4. Okay, yeah, on the surface, it looks like this function's decreasing. You think, so yeah, the rate of change looks negative. But again, we don't know what the function is actually going to be doing between those points. And so, maybe the function goes up for a while and then it drops for a while or something like that. We have no idea. All right. And that leaves E. Obviously, the answer is E. We've ruled everything else out, but let's look at what's going on with that. So this is what a mean value theorem is going to look like in this type of problem. Notice here they talk about something existing, specifically a derivative value existing. Intermediate value theorem talks about a function passing between different points. Those are the values of the original function. This is talking about the derivative being 0. So all you've got to find is some interval where the average rate is 0. And that guarantees that the derivative also would have to be 0 somewhere in that interval, okay? And they were nice here because check it out. If we look at the interval between 0 and 4, if I take f of 4 minus f of 0 all over 4 minus 0, notice that f of 4 is 2 and f of 0 is also 2. So we're going to have 2 minus 2 over 4. And that's going to be equal to 0. So the average rate of change is 0 on the interval. Because the function is continuous and differentiable in the interval, it has to somewhere have a derivative that's also 0. By the way, if you think about this, so the function starting out, I know this doesn't look very good, but the function starting out here at 2 actually, and it goes like this. And so the average rate of change for that function would be the slope of that secant line there. So whether or not it goes way up and then comes back down, or whether or not it goes down and comes back up, it's going to start and end at the same place. And that means somewhere there should be a slope of a tangent line that's also 0. Okay, again, there could be multiple places where it happens. We don't know what the function's doing, but it would have to happen somewhere. So that's what's going on with that mean value theorem problem.